We're now going to take a look at cotangent, which is very similar to tangent and is actually going to look like a shifted and reflected version of it. So something to keep in mind: when tangent is 0, cotangent is undefined. And vice versa, when tangent is 0, when tangent is undefined, cotangent is 0. So what you can do, and this is a little tricky because it's on the other side, but you can flip back and forth. So if we take this table here and flip things over, we're going to have undefined in these 3 spots. Don't change this. I'm just doing this now so we can go and put that in. So undefined here, here, and here. Remember, undefined means vertical asymptote for this. Oh, man. And then when it was undefined, we're now going to switch that over to 0. So here is going to become 0 and 0 at the negative pi over 2 and pi over 2. Everything else stays the same, because if you take the reciprocal of 1 or negative 1, it's still going to be 1 or negative 1. So we'll have 1 here, negative 1 here, 1 and negative 1. Now when we go to graph this, we're putting in an asymptote here. And let me label the axis: negative pi, negative 3 pi over 4, negative pi over 2. And then on the other side. And just like I did before, I'm going to put the original or parent graph in blue so we know which cycle we're working with. So this first one here that's in the negative range, it looks like this. This will not be the cycle we're working with. When we're looking at the cycles that are our original parent graphs, we're looking at the ones closest to the y-axis and also, if possible, on the positive side. So our asymptote at 0 is going to start our cycle for our cotangent graph. And then we have our critical points. We're going to be labeling those A, B, C, and then labeling them off the graph. So just to kind of compare this to our tangent graph, if you flip back, or I'm going to scroll back to the front, it looks pretty much the same, right? But it looks like a reflection. We do have and a shift because we're not starting that cycle at or 0, 0 anymore. So it looks like a negative tangent graph translated. Now our critical points are going to be pi over 4, 1, pi over 2, 0, and 3 pi over 4, negative 1. Our vertical asymptotes, again, we have our visible versus the general. So for visible for this, we have 0 and we have pi. For general, we have x is equal to, and I could put 0 plus, but I'm just going to put pi times k, again, where k is any integer. Our period is still pi, so kind of like sine and cosine, tangent and cotangent have a lot of similarities in terms of how we're going to set them up, look for the asymptotes, and that kind of thing. Symmetry for this is also odd. Now I know there's no point going through the origin, but we do have an asymptote going through the origin, so that kind of counts. And if you do rotate it, it does look the same. Again, there is no amplitude. Our range is negative infinity to infinity. And then the domain is the one that's going to change based on your transformation. So again, all real numbers. minus the set of x values where you have asymptotes. So we're going to have asymptotes at pi times k. So if we did put in a 0 for k, we would get that asymptote of 0. And again, where k is any integer. So now that you have the basics of these two graphs, we are then going to explore together how to graph using the transformations, and then focusing on the parent cycle or the one cycle that we have in blue for both of the graphs.